to register isn't used from any other mass-node in the network. So several fields are protected from this uniqueness requirement. For example, obviously the ProTX hash, the IP address, the voting address, for example, and the public key operator, which is it's at the center of the problem that I'm going to describe. So, few words about the implementation. So how this uniqueness is guaranteed. So each mass-node list has an immutable data structure. So it's a map called unique property map. The key is the hash of the property that we want to protect, and the value is the ProTX hash. And so now that we have this unique property map, we can, when we're about, for example, to register a new mass node, we hash for example, the new IP, and we search in the unique property map. Okay, do we have an IP? Do we have, a key already in the map? For example, the hash of the IP. If yes, then okay, you're not allowed to register this mass node with this IP since it is already used. Similar logic is applied also when you update the mass node. So when you do ProTX update registration, so when you change, for example, either the voting address or the public key operator or both, you could do both in the same transaction. Also in the update service, so when you change an IP, again, when you update the IP, you want to make sure that the new IP isn't used. And also, when you do a revoke, so we are removing a mass node from the list, or when there is a collateral spending, so again it leads to a removal, or when we use the same collateral for a new registration. So this is basically, it is translated as a remove mass node. So keep in mind so that every mass node list has this unique property map inside of it. And when you try to apply a diff, those functions are called in order to guarantee this uniqueness. Can we go please to the next slide? All right, so back to the previous example. So in order to make things simpler for the presentation, so imagine that V19 activated at height 200. So that means that starting from this point, the new BLS scheme activates. And that means that from this moment, when we hash a BLS public key, it is going to be hashed using the new scheme. Hence, the hash will be different from the previous way. So keep this thing in your mind. And so the fork activated, and for any reason, the system, so the node, needs to access the mass node list at height 104. This is just an example. And imagine that the cached mass node lists in the bottom are not present, so they were invalidated. So we need to reconstruct the mass node lists for those heights. So as I explained in the previous slides, we get the last full snapshot before the requested height, which is 104. So in our case, we take the snapshot 100 because we construct the master node list, and then we try to apply one by one the diffs. And imagine that in the height 102, one master node spent their collateral. So we have a removal. The node so tries to apply the diff at 101. So far, so good. So it constructs the full master node list at 101. And now it tries to remove the master node from the diff at 102. And because the scheme, the active scheme has changed, it tries to remove a hash that isn't present in the unique property map that is inside the master node list at 101. So basically, this is the problem that appeared on previous Monday. So as you see, it is, imagine that we don't have caching at all. So we don't cache master node list at all, and we recompute everything from scratch. This problem would be 100% deterministic, since everybody would achieve the same I'm sorry, not achieve, would I forgot the word. Would
everybody would fail successfully.
Yes, thank you, Sam. Okay, so next slide, please. So this was the first part, which is the explanation of the actual problem. So we have another thing to explain. So how come roughly, I think it was 85% of nodes were stuck with this problem, and around 15% of nodes weren't affected by this. So this is the thing I told before about the determinism of the issue. So everything is around the caches and which factors are leading to cache invalidation or complete master node list reconstruction. So it's basically the same thing. So are the reasons to go back in time and request a full master node list in the past? Well, we tend to verify quorums when they are mined. So this requires, verification of quorum member signatures. Also, when with rotation, so diff24 introduced in V18, so we need to reconstruct old shares. So we need to go back in time in the master node lists and recompute them. So the first two dots here are deterministic, but in the combination with SPV clients requesting master node list diffs from the past, and this is fully, fully randomized. I mean, if a mobile client was turned off for several weeks, comparing to another mobile client switched off for just one day, they won't request the same master node list diff. And depending on which node will try to process that request, so this roughly leads to nodes having a different set of cached mass nodes lists. Also, a combination with the last dot, well, a node running for a longer time compared to a node that just restarted also makes the set of cached mass node lists different. So when you combine all this, it for me it can explain the non-determinism of this issue. So why some nodes got stalled and some others could advance. So we are of course working on a fix. So because we identified the first part, so the actual problem with the hashing and the BLS scheme that changed, we could easily write a fix, but it is quite difficult, at least in at the moment, to reproduce on rectest such a scenario, because, for example, on rectest we don't have so many SPV clients requesting different heights at every point. So it is very unlikely to achieve the replication of the problem. Good news, I mean, partially, I think, good news is that by disabling the caching, we were able to actually reproduce the problem and make sure that the fix that we are working on is fixing the problem. We are still under a review and under discussion of the final fix. One solution that we are thinking of is to in the unique property map, we could serialize the public key operator using the scheme that was used when the masternode was registered. And because this is deterministic, then we can safely proceed with all the operations that I described, like add, remove, and update easily and achieve the same hash every time. So I think I'm done with the discussion. I will wait, of course, any questions regarding the problem. And yes, you can continue, Balash.
All right. Do you want to go with the questions right now? Oh,
yeah,
misunderstood.
No, I'm just saying that I will be happy to answer any question regarding the problem.
But after the next part.
Yes, sorry for the confusion.
No worries. Pasta, would you go next?
Yeah, so go ahead and go to the next slide. All right, so this issue kind of occurred over the course of about 16 to 24 hours. We were monitoring the situation right when the network was forking, and we saw the issue. And after that, for a very extended period of time, no blocks were being mined whatsoever. Nothing, transactions were just being added to the mempool and were propagating around the network. But we were beginning to investigate the issue and figure out what was happening. Many hours later, we started seeing a miner mine an invalid chain. And this wouldn't actually be the first time that we would see that throughout the night. There were at least 4 chains that were mined kind of during this stall and recovery. And 2 of them were just invalid no matter what, or conflicting. So the first one that did pop up was the longest invalid chain that got mined. There were quite a few blocks that were mined to it. Interestingly, dot gravity wave kind of hurts us in this manner, where even if only one super tiny miner is mining on a chain, if they find just a couple of blocks, the difficulty is going to plummet, and all of a sudden they're going to be producing blocks very quickly. And it's going to look, at least from a block time perspective, that everything is normal. If you actually look at the amount of work being added to the chain, you'll see that something is very weird. But if you just look at how long it's taking for blocks to form, that will resolve itself very quickly. And so they were able to mine quite a few blocks, even though the chain was invalid on its face, and they didn't actually have that much work really supporting the chain. If you reindexed a node, a V19 node, it will reject that chain. We reindexed probably close to 10 times on different nodes on different systems. And none of the freshly reindexed nodes were able to continue on to that relatively long chain. Some people might know it as kind of, I think it was Pro Hashing that was mining this chain. At the time, we didn't know who was mining it. We didn't have contact with the miner. We were trying to get into contact with as many people as we could to try and really figure out who was mining it and figure out what kind of happened on their systems to where they were mining this invalid chain. But our goal throughout the night was to, maybe there was a bug where, we were falsely considering the chain invalid, or maybe there was a way that we could figure out to add some special case rule where, even though it probably should be invalid, because it does have some work on it, maybe we'll just accept it and add some special case rule and be able to move on to that chain. But it just wasn't possible. It wasn't feasible to accept that pro hashing relatively long chain. So that was the first invalid chain. The second one was created by a miner that we were actually talking with, and we were helping them get their systems, back up and running. And they had incorrectly invalidated a specific block, and that block that they invalidated was chain locked. And so they mined a chain of, I think, something like 20 or 30 blocks that was just on its face conflicting with a chain lock. And we can't have that. Chain locks are immutable, and a block that was chain locked is not going to get orphaned. That's a pretty basic principle of Dash at this point, and it had to be discarded under DIP 8, which is the chain locks DIP. And then there was a third chain that only ended up having one block on it that I saw. There might have been more. Network propagation wasn't amazing, but it seems to me still that it only had one block. And then finally, there was the fourth chain that ended up accumulating the most work and became chain locked once the masternodes all kind of came together on it. So yeah, I was just hoping that this would kind of provide a little bit more detail on kind of the situation on the network. I added in parentheses what version each of these was mined with, or at least to my understanding what they were mined with. But yeah, the pro hashing chain, just, if you reindex, it wasn't a valid chain. It did not follow consensus rules, and maybe it would have been possible to add a special case, but it didn't seem feasible at all. And to me, it still doesn't seem feasible to have added a special case for it. And it just had to be orphaned off in the end. We talked about the issues with the internal state that kind of ended up getting them into this corrupted state. But yeah, people just want, it couldn't be validated. So I think we can move on to the next slide at this point. And I believe the next slide is talking about kind of moving forward. So we ended up releasing v19.1. v19.1 delays the v19 hard fork parameter start date to June 14th. There was some miscommunication early on. That does not mean activation is currently going to happen on June 14th. currently the earliest activation is on July 6th. We did properly communicate that in the release notes, but I think probably both internally and externally, there was some miscommunication about that. And but yeah, the current earliest activation date is July 6th. That could be pushed forward depending on how testing goes. And we might talk about that later on and see if it makes sense to move that forward. But there will be a mandatory update before this release. Everyone on the network will have to upgrade to v19.2, or they will stall once the v19 hard fork logic activates. And we're working on this fix right now. We're working on these things, and we're going to get it out as soon as we can. It'll at the very least be multiple weeks before the activation date on July 6th. We definitely don't want to release a version and say, okay, you have 3 days to upgrade or you're going to stall and get proof of service banned. We want to make sure that our exchange partners and masternodes and everyone like that have sufficient time and sufficient notice to upgrade and not have any degradation of service. Okay, I think we can move on to the next slide now. So we're also briefly just going to talk about kind of our current development. We did make some progress on v20, primarily in the week, not this last week, but the week before that. So SPV client support for the decentralized randomness, the randomness beacon, is now in review. Good job to Odie on making good progress with that. There has been progress on some of the other items on here, but they're still, from a high level point of view, their state hasn't really changed. Individual pull requests have been merged on most of these topics. Guix has had pull requests merged, but the actual, large task of migrating to Guix is still in progress. And asset locks is still in testing. EHF is still in progress, and masternode reward location reallocation is still in review. So you can also see the list of merged pull requests there at the bottom. Some of those are related to v19.1 and kind of delayed activation, but quite a few of them are backports and other kind of changes that we make during our normal kind of release. So I think, Balazs, now, if we want to move on to the questions, I don't know if you have accumulating.
Yeah, let's take a look at the questions. I think the first question refers to all these graphs or slides with the diagrams. Is diff short for difference from the last snapshot then?
Yes, diff is just short for the difference between kind of two diffs, between two lists.
Yes.
Yes.
See, yes.
I was laughing at Pasta saying the diff between two diffs.
I think it is funny that this is all because we are changing the BLS scheme because Dash was too far ahead with its own scheme, right?
Yeah, so we adopted BLS in the very early days of BLS becoming a thing. It was really one of the only cryptographic primitives that we could use to do the aggregate signatures in the way that we needed to. Codablock was kind of the driving force behind implementing and using BLS in the early days, although I'm sure there were other people that I'm forgetting about. It was maybe slightly before my time. But yeah, we adopted BLS very early on. And at the time we used what was kind of a standard library implementation of it. But over time, eventually kind of Ethereum adopted BLS in a number of different ways, I believe. And in that kind of adoption process, the whole kind of cryptographic realm collapsed on a specific standard. And that specific standard was very similar to the standard implemented in the library that we used. And the only difference was in the serialization of the public keys. And that's actually really annoying because it's not like it was a massive change going from the old scheme to the new scheme, but some cryptographer just really wanted some change in the public key for some reason. Maybe there was a very good reason, but yeah, it was really a minor change between the two schemes. The underlying primitives are the same. The mathematics is the same. But yeah, the whole root of this is that we adopted BLS in the very early days of it. And yeah, I think that's good enough for that question. I think we can move on.
All right, thank you very much.
Can I add just a few things? That was actually not the only thing that changed. The extended public key derivation also changed between the two libraries. Just to add that. Also, the public key, you said that the public key changed. It's not that, it's the public key serialization. Just
Yeah,
sorry to be like pinpoint on a few things. Yeah. I would also like to say that it was another one thing, sorry, because I was very involved in this in 2018. It's not the aggregation, it's the threshold recovery, and aggregation and threshold recovery are very different. In fact, we wrote the threshold recovery on BLS ourselves, and that is code that DCG wrote. It wasn't taken from the library. And it's the same code that we are still using, and it's made possible because of properties of BLS. Yeah.
Thank you very much. All right, I see a long question, or a thought process, I should say. Let me just read it out loud. Just to get some clarification on the issue from upgrading BLS scheme. We are all master nodes BLS key upgraded automatically when the MN owners upgrade to V19, ? Or in other words, did the system expect all the master nodes to be using the new BLS scheme at the time of block activation? ?
I'll answer a little bit just to begin. This is if you want to add anything. So the BLS public key, again, as we said, the primitive didn't change. So for people that are not very cryptography oriented, underlying the public key and the private key, you basically have a very, 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 very big number. And this number, probably bigger than the amount of, I was about to say bigger than the amount of atoms in the universe. I don't know, probably not, but very, very, very big number. This number doesn't actually change. So what does change is the serialization. So we didn't really have to upgrade masternode's BLS public key. We had to upgrade the serialization. So the keys stay the same, the serialization doesn't. And because the serialization changes, so does the Merkle root.
And also, I think the question was if we expect all nodes to use the new scheme at the block activation. Yes, we do. For all the PTP messages, the Coinbase Merkle roots, but we, for example, if the fork happened and you are starting a new node, well, in order to parse the old blocks, all the BLS objects contained, for example, on the ProTX, which is old, based on the version of the ProTX, you use the corresponding scheme. So on chain, we have mostly every time a version field, so guiding us which scheme to use. And on the P2P messages and Coinbase Merkle root, we always use the active scheme.
Okay, let me continue the question. So where I ended was, in other words, did the system expect all the elements to be using the new BLS scheme at the time of block activation? If so, does that mean master nodes that didn't update to B19, they are still on legacy BLS scheme? And is that what caused the MN list update issue in apply diff remove MN issue? Question mark. For example, they killed their master node before hard fork activation by moving / spending their collateral, but they were still on legacy BLS scheme.
Well, I explained why the apply diff failed. So roughly because for some reason you need to reconstruct a node list from the past, so from before the fork, and for another reason you don't have the master node cached anywhere, so you need to reconstruct it. So then you have the problem because since now the fork is active and so the new scheme is active, you try to serialize using the new way, while the master node list from the past contains inside of it the hash of the public key computed with legacy scheme. So I'm not sure if I understood correctly, but the explanation for the applied diff is what I just said. I don't know, Sam, do you have any comments?
I was thinking about the number of atoms in the universe. I apologize.
All right, thank you very much. So next question is Codablock still active with Dash?
No, he hasn't been active since 2019, I'd say. Yeah. Anybody, is that correct, guys? 2019, I think.
I think so.
Yeah.
All right.
It was a gradual decrease.
Yeah.
So
another reframing question. If a simplified way to reframe this is that the new BLS scheme didn't mesh with the old scheme, what can/will be done different when this scheme change is again attempted?
Well, so the two schemes cannot just willy-nilly be used together. Like if you try to kind of do operations with both at the same time, it can cause issues. And so that is not exactly what we saw here, but basically the answer is that the way that we'll fix this is that we were trying to use a key in basic mode when we should have been using it in legacy mode. And we should have been serializing a key in legacy to find it in this map. And so we are kind of reviewing these use cases of when we are using what scheme, and we are adding better guardrails so that this issue doesn't happen again and that it'll be solved in 19.2. Odie, do you want to add any detail to that, or do you think that was good?
No, I think it covered the answer.
All right, thank you very much. And after the number of atoms in the universe, let's continue with the platform team update. Thank you very much. Thank you, Odie. Thank you, Pasta, and everyone who were answering.
I would like to say, I would like to thank the core team for everything that they did last week as well. It was a very stressful week for actually most yeah, mostly all of DCG and probably a lot of community members as well. But we have to think about we have to look at the positives, and the positives are that other than some chains like being invalid, no actual economic transaction was reversed. The only transaction that I know of that was reversed was one that created a Evo node. Somebody was like, "Ooh, cannot wait," and they created the first Evo node. But obviously that had to be reversed. But the person got back there. I mean, I mean, they didn't lose any money, obviously, because the transactions just the dash just went back to the old collateral area. So
it was you.
It was not me. But I really I mean, that person was really wanted to show that, hey, it's possible, and hey, that it is interesting to know that that transaction did get mined in the incorrect chain. So we have a little bit of extra testing there. Thanks, mysterious person. Yeah, let's move on to platform. One other thing to talk about platform is because of, well, you know, a lot of some people helping out on core, things didn't go as strongly as they did in the previous review, but we still got a lot accomplished, and we're going to talk about that. So let's start. So the first thing that happened, and you know, a lot of things you see here is around testing. And I would say that yeah, that was one of the biggest things that happened in platform in this sprint, and you know, we'll show that. So sorry. First thing is that we partially stabilized the platform test suite. And why do we say this is done? Because the goal here was not to make the entire test suite run, because the test suite has so many tests, and a lot of these tests are probably no longer accurate, right? Because there was a lot of changes that happened since they were introduced. So what we did is we got the platform test suite, and we got about 80% of it. The tests that we know are very important, and every test that we're like, that test probably is no longer needed, we basically put a note about it, and we're going to investigate if the test is actually needed. So all of the tests that we know were needed, we passed, and that's why we're writing partially stabilized. And it's going to take time in the testing phase to go through the rest of the tests to say, okay, are we going to need these? Or are we not going to need these? Yeah. So that was one thing, and that's actually a very big accomplishment of this sprint, that the test suite is passing and things are now green in V0.25. Next one, I'm going to pass to Javid to talk about.
Oh, hello there, everyone. So there are a few things that we did this sprint. Is first of all, we've updated our Coinbase transaction payload to represent Core V20, keeping the backward compatibility as well. So changes are non-breaking, so everything should be fine. And the second thing is we've accomplishing Dashmate end-to-end tests. So there are local testing as well as testnet testing. And this is currently on the final stages. So a few tweaks, and this is going to be on review and hopefully done. So that's kind of it. Hopefully I don't miss anything. Who should I pass it next?
Łukasz?
Yeah, hi. So let me refer a few different topics. First one is CI/CD, so continuous integration and continuous delivery systems, also known as GitHub runners and GitHub actions and workflows. When we push something, it gets built, and this build process takes quite long time. And we are working on refactoring of that and change to use our own runners, our own cache instead of GitHub provided, because it's a big limitation for us. This is in progress and it will take some time from now, because first of all, we work on that with the team that is also taking care of the whole infrastructure, so they don't put much time into this topic. And second thing is that when you test something, it takes multiple minutes or sometimes hour to go through the pipeline, so it's not a quick task to do and to test everything correctly. In terms of development, I worked on logging in Drive. So Drive ABCI, which is right now in Rust, is capable of logging to multiple destinations with multiple verbosity levels. So this is requested by our developers. It's there, and we can have separate log stream targeted for Elasticsearch stack for log management, and separate logs for humans that are in a different format. In this case, more human friendly. So this is done. Another thing I worked on is the service status of Drive. So the need was to report if Drive is up or not. And as part of this task, or as an extension of this task, we introduced a Prometheus compatible interface to gather and share metrics from Drive. So right now we can generate or extract from Drive some basic metrics as a proof of concept. Over time, I think we can just increase the number of metrics that are exported from Drive for better monitoring and maintenance tasks. It's mainly targeted at sysops, the DevOps people with such skills, but also developers can use it when optimizing performance or checking why it's so slow. I will show it in more details in a moment. On top of that, I worked on a few smaller tasks. One was to control wasm bindgen CLI version. That's a tool that we use, but it needs to be in sync with the sources we use. And yeah, I just did some auto detection code and improved the README, because when I was testing, I discovered some missing dependencies. So on the next slide, we can see a proof of concept on what these metrics are. So right now we can monitor, and of course we can define some alerts to see what's the block height, what's the last block time. This is a screenshot, so the time is in past, but basically it's updated in real time. I think every 5 seconds on my test bed. And we also have some interesting statistics that tell us, for example, that the finalized block ABCI request in 50% with probability of 0.5, so half of requests should end at or under 6 milliseconds. So that can be useful if we get into some performance issues to monitor what's happening. We also can see how many requests were executed. So all that information can be easily gathered and displayed and analyzed. Of course, this is just a proof of concept, so we still need a good instrumentation system to be built to be able to use that information, and we need to add more metrics that will be useful for the team to monitor running systems, right? But that's just one step in that direction. So that's it on my side.
Thank you very much. Kostya, would you go next?
Yes, sure. So we continued to stabilizing Dashmate. And the first one was about ZeroSSL. ZeroSSL is the only SSL provider that we support at this time, and we improved our reportings to make errors more clear to the users. The second one, we just changed the labels for ports because they were a bit confusing. Now it's more clear what we want to get from users in Dashmate. Verify C bindings. We need to have C bindings because for iOS, because C bindings is like a bridge between different programming languages. But it's still not ready. We are on this. New identity credit transfer transition is the new type of state transition that allows users to transfer credits between different identities. Before we had only top up and withdrawal transitions, so now we will have the ability to transfer credits directly. And I should pass my torch to the next person.
Dima.
Hello, everyone. Well, on the past sprint, I worked on stabilization of Rust dashboard library, and currently I'm done with the first part of stabilization. This is related to the making library compilable. All unit test was fixed, and also GitHub says also green. So, and currently I'm working on the next iteration is related to a integration X11 hash algorithm against SHA 256 because the Bitcoin has this algorithm to compute the block hash. So, but Dash has another one, which is X11. So, yeah, we just need to support it in our Rust core library. I already supported it, and currently I'm fixing unit test because all predefined values which we have in our test cases are currently incorrect because they used completely different hash algorithm. So, okay, I'm done. Who's next?
All right, thank you very much, Singer. Anton, would you go next?
Yeah, sure. I'm sorry for any connection problems I might have today. My internet isn't all that good, unfortunately. Can you hear me?
Yes.
We can.
Okay, good. Yeah, so this sprint, I worked mostly on data contract mutability, and I was visiting data contract mutability. So what data contract mutability is, that's we've added a new field, data contract, which is a data contract config. Data contract config allows you to set different data contract parameters. For example, whether you can update documents inside the data contract, whether you want to keep the data contract changes history or you don't, things of that nature. And so this sprint, I revisited all this functionality, covered it with tests. And two particular places I was working on is the first one is the read-only field in data contract. So now the data contract can specify that its documents are immutable, which means you can never update any document in a data contract, even if the schema is backwards compatible between two versions. You will still be not allowed to update anything in data contract. The second one is data contract history. So I made sure that data contract history works as expected, that we can save data contract history according to the field set in config. For example, if the contract, if you specify that contract should keep history inside the data contracts config, then the history should be kept. And then I've proceeded to implement the ABCI method to fetch the history of the data contract changes and also proofs for the history that you get back. You can fetch the history of data contract using limit, offset, and start at date. And the same goes for proofs. So now it's possible to verify the data contract history and the changes of the data contract on the light clients. Let's put them this way, because there is now an API method to do so. And that would be it for me. So, Balash, I'm giving the word back to you.
Yes.
Did you continue?
It's me. But I would like to say one thing. I have these asterisks that I need to put next to things because I'm like that. You said recently we added the mutability fields. The config fields. It was about a year ago. Not really recently. But yes, it was the issue, and I have to thank Anton so much for his work, is that it was. I think your internet went out. It was partially implemented, so it now is very close to being completely 100% good, and verified with tests. And Anton did an amazing job there, and he has a very very big pull request actually. So well done, Anton. So. I'll go on to the next part, the core reward distribution. So, the reward distribution is actually one of the big items that, one of the things that was in what we still needed to accomplish. Obviously, a lot of other stuff was also accomplished in the sprint that wasn't always as obvious, but yeah, core reward distribution is very obvious. It's close to being done. What currently exists, what currently is done is the calculation of the reward distribution and the distribution to proposers. What isn't properly done yet, and why this is still in progress, is because the distribution is based off of a 7% decrease in core per year, and that logic of the different epochs, core epochs, hasn't been properly integrated yet. So once that's integrated, I believe this will be done, and it will be another big item. The versioning document explaining how we are versioning platform is currently in review. The goal here is to make this into a dip and to give it to our community. We have a lot of documents that also are in a semi-final state, but they were never finished. The point was always to get them to a semi-final state, but not the final state, because the problem is that we still modify things as we go, small things, but it's never fun to release something, have it be a spec, and then have to modify it. So, but versioning probably will be able to release it quite soon. Then we go into versioning. So versioning is a very big task. It's still in progress. I was personally working on it, and yeah, so because of I was really hoping to say today, oh, it's done, but I personally was working with the core team a lot last week, and I wasn't able to spend as much time on versioning as I wish. So it's still in progress, and I hope it will be completed soon. Okay, let's go on. Oh yeah, and we also have like a very big number of resolved unplanned issues. The first one is actually not unplanned. It sadly got in here. I think it got moved by accident. This was previously on the previous slide. Must have updated. So one issue that me and Wisdom had realized was that we had an issue with GroveDB references in a specific rare, well, not super rare situation, and it was integrating and it was causing a lot of problems with proofs. We wrote a test for it. This was about 2 weeks ago, and yeah, we realized that this was a problem, and we were actually quite worried about it because it was actually a pretty big problem. Thankfully, within 2 days, we were able to make a fix on GroveDB side and make a fix in Drive side. So it's one of those big issues that ended up not being big, and everything is working perfectly right now. We added to GroveDB the ability to do a reference refresh, which is a special type of operation in GroveDB. Basically, to go a little bit into it, but not super into it, a lot of databases have bidirectional references. Bidirectional references are good, but they're not as efficient as unidirectional references. And we have the more optimized unidirectional references, but this comes at a cost, and the cost is it's a little bit harder to maintain. And it's maintained in Drive. And yeah, so, but anyways, in the end, all done, no problem. So yeah, we can move on to the next one. DPNS trigger fix. Yeah, so this was a what was this? Yeah, we had a reported issue where if we were to update the if we were to try to insert something that was not in the root, I think the insert into DPNS wouldn't work. So that was also fixed. We had an issue where checktx could panic, and basically the point is that checktx should never panic, should never take down platform, no matter what the situation. So yeah, because otherwise you could find a way to actually break platform. That's now been fixed. I believe the next 3 might be better done, explained by somebody else.
Yeah, sure, I'll help you.
Sure.
So this one, the problem with the handling instant logs in our JavaScript wallet library, it's pretty old problem, and basically it's originated. It's basically the reason is how the wallet library and DAPI works together. So when during the sync process, when we create blue filter and send it to the DAPI, we get back transactions, and since we fill the gap, we create a new bloom filter in the wallet and reconnect with the new bloom filter to the DAPI. And unfortunately, during this reconnection, we lost the instant log, what was reserved for this connection session with the wallet. So we fixed this logic in the wallet library, and now we're receiving instant logs as well. We're not verifying it yet. It will be done later.
when we will work on the SPV functionality. The next one is our colleagues from the core team. They changed the message of the error for sure to make it more verbose, and we just handle the new message. That's it. The last one, I think it was related to your work, Lukasz, but I can just really quick explain it. So we changed the Docker file last sprint to speed up the process. So instead of having multiple Docker files for each component, now we have one single one with the multi-stages for each package, and it gives us some speed up during the build process. And there was a small bug there that we didn't define the environment variable for the Dashmate home path. That's it. Thank you.
Thank you. Sam, would you take over?
It's back to you, yeah, Sam.
Yep. So we're currently on deployment 9 of version 0.25, and a lot of new stuff is working. Basically, before we were having some nodes that were having issues with the V20 hard fork, updating, starting them. It was only one node that was having a problem, and it was actually always one node having a problem, one or two nodes. It was not a majority, but now that's been fixed, and now there's literally 0 problems on the hard fork activation mechanism. We also had an issue where if we would stop platform and restart it, like get a new version and put it in, sometimes that would not work. Actually, not sometimes, that would never work before. And we fixed that about 2 weeks ago. But then, yeah, so now we have no issues there. A lot of the fixes that we see that were explained earlier were also put into this version. And currently we only have one known issue in Test Suite. Test Suite is the high-level tests that basically bombard the DevNet with, creating identities, running DashPay, creating contact requests, like the whole shebang. And yeah, so that's actually pretty good. We're one known issue, I say, because I'm sure there are going to be more. This is not like the last one, but we are currently, we only know of one, right? So it's a lot better than it was 2 weeks ago, where, well, I don't think we could even run Test Suite on it. So good progress. So going back to what is left to do, there's obviously a lot of peripheral stuff that we've also explained, and there is going to be more, but these are the big items. We have the versioning, which is in progress, and the difference here between before is that the core block reward processing is also in progress, and I would say more close to being done than to being started, but it is also a smaller one here. Yeah, and then basically everything else is still in the state that it was at before. Overall, wish more had happened, but it was a very interesting sprint. And we still got a lot done.
Thank you very much. So shall we move on to the questions? The first question is, transferring credits between identities, if an identity is attached to a name, then someone can send credits to any name with no address or setup required.
Yeah, I'll take that one. Yeah, That is correct. The one thing to note is that there's absolutely zero privacy, right? So DashPay, when you're using DashPay in your mobile wallet, it's going to be an instant thing, and you're going to be using the Dash Core payment chain, and it's made for this, right? Nobody outside of you and the person that receives the transfer of Dash will know who sent to who, right? However, if you're using the identity credit transfer feature, everybody will know. I mean, it's just a lookup. So this feature is a good thing to have, obviously, right? It's better to have it than not. However, yeah, you really shouldn't. I mean, should or shouldn't is a loaded term, but it's not ideal to be used for payments, right? You don't want all your payment history to be known. But you could use it, for example, for things that maybe are public. For example, a distribution of a game, right, where you want the information to be public to everybody, right? So like the reward of winning a specific game, or there are a lot of situations where you want a transfer to be known publicly to everybody.
Thank you very much. Will there be a block explorer for Evo credits?
Will there be a block explorer for Evo credits? So we have to understand one thing, is that the way platform works is that anybody can query it, right? So you can query for any information that you care about. So what is really needed is not like a daemon really running in the background that is big, but just an interface through DAPI that queries the information that you care about. No, well, currently we don't have that in Dash Core. Hopefully some group that is not Dash Core group will be able to take that on. I do think, if I'm not
Incubator
mistaken,
did something.
yeah, exactly. I was going to
Actually.
say that. I think the incubator has something, but I don't know really the state on it. I haven't paid attention recently.
We worked on something like called Platform Console long ago.
Yeah, a long time ago. But yeah.
I think the closer we to release, we will have more tools like this around our ecosystem.
Yeah, and just to be 100% clear, I'm not blaming incubator in any single way about it not being more close to complete, because don't know. But it was without a functional testnet running platform for multiple months in the past, it was very hard for them to continue on some of these projects.
Thank you very much. The real question: will V25 identity credits transfer or Dash instance stand be faster? I can't wait to find out.
So under normal network load, I would imagine instance send to be much faster. I would imagine a transfer of credits to take anywhere between 3 and 10 seconds. That's just, these are estimates, guesstimates. And an instance send to take maybe 1. So I would say instance send would be much faster.
Thank you. Is there any scenario where miners could continue to mine valid blocks if, for whatever reason, master nodes were not producing instant stand locks or chain locks?
Wait, we're going back to core. Where did that question come from?
Ryan just asked it.
Okay, is there any valid any? I'm trying to understand the question.
Pasta, are you around? So is there any scenario where miners could continue to mine valid blocks if, for whatever reason, master nodes were not producing instant send locks or chain locks?
Yes, I mean, yes, obviously. So if there are no chain locks or instant send locks, miners can continue to mine valid blocks. We've seen this multiple times in the past. You know, there was a time of, I feel like maybe half a year ago, somebody correct me if I'm wrong, where we didn't get a chain lock for some period of time. And yeah, there were valid blocks. And then eventually the last of these valid blocks was chain locked.
Any talk of getting private send on mobile?
Yes, talk of it. Talk of it. But
nothing on the roadmap as far as I know.
Yes. You know, I'm hoping that Brian will be able to answer this question at some point. Brian is our head of product.
All right. Thank you very much. That's it for today. This was a marathon, I guess, for everybody. Thank you for the questions, for the comments, and for the feedbacks. And see you in 2 weeks. Thanks, everybody. Bye-bye.